My name is Martin Fahn, and I am a solutions architect with CalLogic Software. In this video demonstration, we'll be talking about the latest capability provided in ECX 2.6, known as file system integration. Prior to 2.6, ECX was able to manage copy data by communicating directly to the application, hypervisor, or storage layers. Initially, application support was limited to databases running within virtual machines, but with more recent changes to the platform, this was extended to databases living on physical machines as well. File system integration takes this one step further by allowing ECX to communicate directly to the operating system on a physical or virtual machine. From here, ECX can drive copy data management from a server-centric perspective versus a storage-centric perspective. For example, Windows drive letters whose LUNs are hosted on supported storage platforms like Pure can be easily identified and selected in a file system backup job and snapshotted at the storage level. These storage snapshots can then be automated and restored to other registered file system servers as different drive letters or mount points. Let's see how this works in a demonstration. We'll first configure our file system server. To do so, click the Configure tab and register a new application server of type file system. Specify the host name and IP address for the server. And select an OS type from the drop-down list. Remember, there are no agents to administer with ECX, so the OS type selection will determine the binaries ECX pushes to the box at runtime so as to perform administrative operations on it. Finally, select an existing credential or create a new credential that has administrative privileges to the server. In this example, we'll use a previously defined local Windows administrator. By default, upon completion of the registration, the server will be added to an inventory job that will perform a discovery of every disk on the server and check whether those mount points correspond to volumes on the SAN. Once the inventory process is completed, define a backup job for the file system by going to the Jobs tab. Expand the file system section and right-click on the file system type. Select Backup. Expand the server of the file system that you would like to protect. Notice here that application servers like SQL servers are also expandable and display mount points instead of the logical database names. Mount points that resolve to supported storage arrays like the U and the V drive will be selectable, while local disks that are attached to the server like the C drive will not. Pre and post scripts are also very helpful features that perform some operation on the box before and after the storage snapshot is taken. These scripts allow you to perform a customized operation on the server like stopping or starting a service to quiet the database running on the volume. You can define pre and post scripts in the Advanced tab. I can upload a script using the Upload button. In this example, a batch file has already been configured and uploaded to the appliance. This simple salutation rule.bat program performs an echo of the argument that I passed to it and writes it to a corresponding text file on the storage volume using the same file name parameter as the parameter. So for example, for my prescript, I would like to say hello or pass it an argument of hello. And then for my postscript, I will pass it an argument of goodbye. I can also select the identity and the application server on which I would like to run this script. So let's use the local administrator for the file system application server that we just added to the enterprise. Select the SLA and give it a job name. In this case, I want it to run every hour on the hour and keep it for a day. And finally, click the Create Job button. An example backup job has been previously created and run to show the orchestration task performed when a file system is protected. In this example, our prescript is invoked and then drives letter U and V are discovered on the file system server, and the LUNs to which they correspond to are resolved to pure storage volumes. From here, ECX can snapshot the volume on the peer, catalog its location, and execute the postscript. you can see that upon running the backup file system job, that 2 text files on drives letter U have been created. And these text files just simply output the echo statement parameters that I specified, hello world, and a date timestamp, in addition to goodbye world. During restore operations, these snapshots can be mounted as LUNs to the original or alternate file system or application servers of the same OS type. To define a restore, right-click the file system object in the Jobs tab and select Restore from the context menu. Select the template for restore and drill down and select the volume from the file system backup that you want to restore. In this case, we'd like to restore the U drive. The catalog keeps track of the snapshot copies. In this case, I have copies located in New Jersey, and I can choose the version of the copy that I have. Since this is an hourly backup, I should see snapshots for each hour that this backup job ran. Finally, select the destination that you want to restore to. In this case, it could be either back to the original file system server or an alternate application server that I have scanned into my enterprise. I will mount this drive letter as the K drive to the same server and create this job definition. And click Create Job. My restore job has been previously defined, and you can see that I've executed it. It is now in a status of resource active. Taking a look at the automation task performed during the restore operation, I can see that ECX loaded the snapshot copy, presented it up as a LUN, and mounted that LUN to my Win2K12FS server. And jumping to the server, I should now see a K drive mounted to that server with a hello and goodbye text file. In this case, notice that the goodbye text file is actually an hour before the hello text file, different from the current volume in which the goodbye text file is actually created by the postscript that runs after the storage snapshot's taken. Because that postscript runs after the storage snapshot's taken, the snapshot that we mounted is actually displaying the goodbye text file from the previous backup job. This backup and restore automation at the file system level, combined with other capabilities like pre and postscript invocation, present broad implications that will benefit storage, server, and application administrators alike by extending copy data management capabilities to databases not natively supported by ECX, or having copy data management for generic file system servers whose storage is centrally located on a SAN. We hope you found this video informative and helpful. If you'd like additional information, you can on how ECX can manage copy data in your enterprise, you can visit our website at www.catalogicsoftware.com. Thank you for your time.